In this video I'll be talking about volume rendering, and in specific I'll be talking about two volume rendering algorithm. One is texture based volume rendering algorithm, and second one is the raycasting algorithm. So what is a texture based algorithm? First let's see what is volume rendering, and then what is a texture based volume rendering algorithm and a raycasting algorithm. So what is basically volume rendering? In the previous video I was talking about we have volume data, so it's something like slices. It's a three-dimensional array of data. It's like I have some numbers here, 99, 100, and here 87. Similarly there are numbers, and it's in 3 dimensions. So I have to show this 3-dimensional data on a 2D screen which has only 2 dimensions, x and y. In this case I had x, y and z, 3 dimensions. So how can we show a 3-dimensional data in a 2-dimensional screen? This mapping of the 3-dimension to 2-dimension is called as volume rendering. Before telling about what is texture based volume rendering algorithm, I'll talk about something called texture mapping. In the figure that I have put here, this is a texture. It's nothing but some pattern. We have some figure. It may be a cylinder or any three-dimensional data. It may be a cube or any 3D volume data. So if it just looks very normal, it's not it does not look good when we see it in its original form. So in texture mapping we use a simple texture, repeat it over the entire volume, and it forms something like this. This looks quite beautiful. It's just like painting your house with some pattern. Just painting house, some pattern, something like that. You have some raw data, you just add some texture and it becomes some beautiful data. So to do this we use texture mapping. Now how we use this texture mapping to the 3D volume data in case of visualization, and how fast can it be? This texture mapping is supported by the graphics processing unit. Since the texture mapping is supported by the graphics processing unit, this is really faster. So it's basically supported in the hardware of the graphic processing unit. It's you can tell it as the basic calculations that the hardware does to do such mapping, the texture mapping. It's usually GPU supports texture mapping because GPU is added into a PC for gaming purpose. Usually you see nice texture mapped objects in games. So it's basically a part of GPU that supports texture mapping. So since hardware supports texture mapping, the texture mapping is really faster. So in our volume data, what happens is if we have some volume data, we just map it to some textures, and that will give us a visualized colorful data. So it's something colorful data we see after visualizing the entire 3D data. In case of texture mapping, these textures, whatever the pattern may be, these are pre-calculated by the GPU, and it is interpolated or mapped to the raw data whenever we are going to do the volume rendering or displaying on the screen on the 2D data. So you may ask, what's this XY, and there's some stacked pieces, and YZ that are stacked vertically, and XZ that are stacked one back to the other. Usually in 3D data, when it is to be displayed on the screen, we can see a data from three angles. It may be this way, or it may be this way, or it may be this way. So these are the three. If it may be this is the same line, this is one of the view line, and this is one of the view line. It may be this way or from the top, and this is one of the view lines. So depending on the view lines, one of the stacked texture maps is selected. If I am seeing from the top of the data, if I want to see the data in this view line, then this texture map is mapped using interpolation, and the data is shown. If I am seeing in this direction, then this texture map is mapped to this data, and it is shown. And if I am seeing in this direction, this texture map, which is pre-calculated, is mapped to the 3D data, and the visualized the rendered volume is shown on the screen. So it's basically faster to interpolate the texture map to the volume data and show it on the screen. Now the question arises, why should you calculate to all the points in the 3D data? It's like have some points in the back side of the volume, and that may not be displayed on the screen. In the 2D screen, it may not be displayed, you may not see it. Why should you simply do the calculations? It may be some interpolation, like this point in the texture map is mapping to this point, and there may be some calculations. It may be faster, but why should you simply do it and waste the time of the GPU when you have large data to be processed? So to reduce the number of calculations to be done, we use some